Hi everyone, this video is on the mixed exercise 11 question 22. So in part A, we want to show that the general solution to this differential equation can be written in the form x squared plus y minus k squared, y minus k squared is equal to c. So we can obviously use separation of variables because if we do a cross multiplication, then we'll have k minus y dy is equal to x dx, and k is just a constant in this case. So now we can integrate both sides, and on the left we'll simply have um, a reverse chain rule, because remember that because we did a cross multiplication of k minus y, so now we integrate this as a bracket. So don't mix this up with something like this where we just integrate each of them separately, because we just multiply the entire thing by this bracket. So that's why we treat this as a single bracket, and we can use the reverse chain rule for this integral. Basically we can have a guess that it's going to be k minus y squared, and because we just add 1 to the power, and then let's just differentiate this and adjust this. So if we differentiate, we'll get a half times minus 1 k minus y squared, which is minus a half k minus y squared. But clearly you can see that actually I don't know why I wrote half. It's just 2, right? When we differentiate, 2 comes down and it becomes minus 2 times k minus y squared. And clearly here we don't have this minus to outside, so therefore this is the answer, minus a half, because that minus a half cancels out with this minus 2. Right, so now the answer, as we showed, is minus k minus y squared over 2 is equal to. Now the integral of x is just half x squared plus c. C is the constant of integration. Now for this part we just need to just rearrange this, right? So we can basically write half x squared and then add this term to both sides, which gives us k minus y squared over 2 is equal to, let's say, a, because just when we or actually we could have just, at the beginning written c, which is the constant of integration here, so that when we change then it just remains c. And yeah, so that's basically the form that we wanted to show. And in part B, we want to describe the family of curves that satisfy this differential equation where k is equal to 2. So when k is equal to 2, we'll have half x squared plus 2 minus y squared over 2 is equal to c. And I think this is very clear that this gives us circles with center 0, 2, right? And radius is c, because, or actually the square root of c, because the center of the circle obviously here is just 0, because x, we just have x, but here we have 2 minus y, so we set this equal to 0 and then we'll get 2. And the reason that we have concentric circles is just because based on the value of c, we'll have different circles, right? Because the radius varies as the value of c varies. Therefore, we'll have circles, more basically infinitely many circles. It just depends on the values of c.